Today we're going to start with so we know all the functional groups up till now, and now we're going to do the types of reactions. So what all reactions do you think we have? We have combustion reactions, we have combustion reactions, we have oxidation reactions, we have reduction reactions, we have esterification reactions, and seventh we have the oxidation, reduction, elimination, and substitution reaction. You understand? So this is an example. These are the types of reactions that we will be seeing in the entire chapter. Right, Ayush? Okay. Now understand. How does these examples work? First, we have the combustion reaction. Just see. Just see. When we talk about the combustion reactions, when we talk of the combustion reactions, just see how does it work. Combustion means burning anything in the presence of burning anything in the presence of oxygen. In the presence of oxygen. Yes or no? So when the amount of
Yeah.
oxygen is in excess quantity, when the amount of oxygen is present in the excess quantity, then you call it as a complete combustion. Then you call it as a complete combustion. Yes or no? And when the oxygen's O2 is present in less quantity, it is incomplete combustion. It is incomplete combustion. In incomplete combustion, the products of carbon monoxide and water. And in complete combustion, the products are carbon dioxide and water. You understand? So you need to know the products of combustion in the incomplete combustion, right? So you need to know the products of complete combustion and incomplete combustion. Understood? So this would be water.
Yeah.
This would be water. And also in the incomplete combustion, sooty particles shall be produced. Sooty particles shall be produced. What are sooty particles? The sooty particles are unburnt. The sooty particles are unburnt or partially burnt carbon particles. Or partially burnt carbon particles. Okay. So, for example, when
Yeah.
I'm talking about the combustion reactions, right? When we are talking about the combustion reactions, what exactly happens in the combustion reaction? Just see, understand. When I'm writing CH4 and you write down O2, you put an arrow and a delta sign. Delta sign means heated. So, this is methane gas. Methane gas is a kind of hydrocarbon. Why hydrocarbon? Made up of carbon and hydrogen. So when you burn it with oxygen, I hope you're understanding that it is going to form carbon dioxide and water. And then you just have to balance the number of oxygens and hydrogens. So for example, carbon dioxide we have CH4 and we have O2. So it's like, CH4 plus
Yeah.
O2 shall give you what? CO2 plus H2O. So I have four H's right here, so I'll put two here. And I will balance the oxygen exactly in the end. Why am I going to do that? Just tell me. Because when you are saying CO2 and 2H2O, you understand? So hydrogens are 2, 2 times 2, 4, and 2 times 1 shall be 2. 2 plus 2, 4. So I have O2 here, so don't you think I should put 2 O2 here? So it shall become CH4 plus 2 O2. Understood or not? And this is going to be my
Yeah.
balanced complete combustion. And you understand that here the flame, obviously methane gas would be burning. So when something burns completely, a lot of blue flame is produced. A lot of blue flame is produced. You understand my point, right? So
Yeah.
you can burn any, right? So you can burn any hydrocarbon. Like for example, if you say C2H6 plus O2 and delta and heat. So you have CO2 and H2O. So definitely, when you're burning any hydrocarbon, carbon dioxide and water shall be produced. Very simple, right? And now you balance the equation again. So what are you left with? So you are left with H6 is 6 hydrogens here. So you put a 3 here because 3 times. It means that you have taken 3 molecules of water and 2, 2, 2. Basically, that means what? It is going to be 6. And from here, oxygens would be how much? Oxygens would be H2O if you're taking 3 molecules, H2O, H2O, H2O. So 3 atoms of oxygen would be there. And when 3 atoms of oxygen are there and 2 atoms of oxygen are coming from CO2. So let me put 2 here because there are 2 carbons here. So that means I have taken 2 molecules of carbon dioxide. So how many atoms of carbon? 2 atoms of carbon and 4 atoms of oxygen. And 4 atoms of oxygen, 7 oxygen because 4 here and 3 here. So 7 oxygen atoms. Are you understanding my point? But here we have 7
Yeah.
O2, only 2 oxygen atoms in one molecule. So don't you think you should put 7 over 2 here? Because when you do 7 over 2
Yeah.
times 2, so 2 cancels 2, so you are left with 7. You understand? So now, but when you're balancing the equation, Ayush, you are not supposed to put the fractional coefficients. You see this coefficient 7 over 2? This 7 over
Yeah.
2 should not be fractional. So what do I do? What do I do to remove this fractional coefficient? I would multiply my entire equation with 2. So my final balanced equation shall become 2 times C2H6 plus 7O2 will give me 4CO2 plus 6H2O and heat. Understood or not? Yes or no?
Yeah.
So this is the combustion
Yeah.
process. You have to remember that lot of energy is produced. Lot of energy is produced and blue flame shall be produced. Blue flame shall be produced. Understood or not?
Yeah.
Any doubts on this?
No.
Right? So this is how you write down the equation of complete combustion where oxygen is in excess quantity. Understood or not?
Yeah.
Right? And when we have to
CO
write
plus
down the
H2.
incomplete combustion, so I'm going to write down, let's suppose we have CH4 and O2. So I'm going to write down CO2 and water. Yes or no? And what would happen then?
Yeah.
You tell me. What would happen then? So it is going to become H2O is there. So I'm not going to write down CO2, I'm going to write down CO. So carbon monoxide plus water. You understand? Plus
Yeah.
heat is produced, but less heat is produced. Less heat is produced, and bluish or reddish flame or yellowish flame shall be produced. Yellowish or reddish flame shall be produced. So not much energy, and you just have to balance it out. So you will have CH4 is right here. So you put it right here. And carbon is just one. So hydrogens I have balanced here. Now how many oxygens do I have right now? H2O, H2O2 molecules. So every molecule having one O atoms. So we will have single oxygen atoms right here and one atom here. So what do you think we have it right here? Tell me. So we have H2 and we have H2 and CO. So we have three oxygen atoms, isn't it? So how should I
Yeah.
make this three? So don't you think it is, because see, understand it is O2. So on the right side, if you think if you have eight oxygen atoms, I would have simply written four. But in reality, what is happening, Ayush? Tell me. In reality, what is happening? You tell me.
It's fraction.
It is a fraction. It is an odd number. So if it is an odd number, what do you think I should put it right here? The odd number by 2? Because it would be either 1.5 times 2 shall give you O2. I hope you're understanding.
Yeah.
Yes or no? So my point of telling you this is that 3 over 2 times O2, if you have this, what does that mean? Tell me. What does that mean? That simply means when you're writing CH4 plus 3 over 2. So I do not need a fractional coefficient. So now to remove this, I will take a entirely, I will multiply this equation with 2. And that's how we properly balance the equation. So this becomes 2 times CH4 plus 3O2. You understand? Should give
Yeah.
me 2 carbon monoxide plus 4 H2. Understand or not?
Yeah. I understand.
Yes or no? And
Yeah.
again, the sooty particles are produced. That would mean that methane is not fully burnt. So it's like, when you burn a lot of garbage, when you collect a lot of garbage, the substitution reactions. Next type of reactions that we have is the substitution reactions. What is a substitution reaction? Just understand. When we talk about the substitution reactions, you see, we have, let's suppose, CH4. So what is CH4? Just see. C, H, 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 and H. And if I add chlorine to this, 1H basically, what is chlorine? I hope you understand chlorine is something like this: Cl, single bond, Cl, isn't it? So 1 and 2.
Yeah.
So I hope you're understanding that it is HCl. So it shall be what? It shall be C, H, 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 and minus HCl, and that one H gets replaced by chlorine. You understand? So this is
Yeah.
substitution, that one H is being substituted by chlorine. And what happens to the another chlorine? What happens to another chlorine? Just tell me. That this chlorine atoms are basically, one chlorine atom is being taken away by this. It shall be HCl. Right? So it shall be
Yeah.
HCl. Understood or not? So similarly,
Yeah.
if I have one ethane molecule, if I have
But
one,
why are they exchange?
right? So what is happening in all these reactions? We have C, H4 and Cl. C, H4 and Cl. So Cl2 we are writing down like this. So any alkane plus Cl2 in the presence of sunlight, what happens? So Cl2 basically means two Cls having a having a covalent bond. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yes or no? So I
Yeah.
hope you're understanding that this shall be cross. So what do you think we have? We have chlorine here and HCl breaks down like this. So HCl is being taken away because of the sunlight, and one H basically gets substituted by this chlorine connecting right here at this carbon. So what do you think we have? C and
Yeah.
C, H and H, H and H, H and Cl. Understood or not?
Yeah.
So that is how we have this particular structure. Understood or not?
Yeah.
Right? So this is understand one thing, that substitution reactions are given by only alkenes. That's a property of alkenes, That's a property of alkanes. So in substitution reaction, one of the hydrogens of the alkane, like in methane, we have 4H. 1H is being substituted by chlorine, right?
Yeah.
Now understand. So another reaction that is possible is, just write down. It would be, it would be what? We have, you know, nitration of alkanes. What is nitration of alkanes? Understand? So nitration of alkanes would be what? Nitration of alkanes would be like this. So you have methane, CH4, and if you add concentrated H2SO4, and if you add not just concentrated H2SO4, only concentrated HNO3. So HNO3 would do what? It was going to replace one H and substitute the group nitro to this. So you will have NO2. So you will have nitromethane. Nitromethane. And this was methane. You understand? Similarly, what do you think we have? We have methane or ethane. And if you add concentrated HNO3 to that, so what does concentrated HNO3 does? It replaces one H. But this is possible only when you are adding HNO3 in an alkane. Because in a different compound, in a different category of compound, if it would have been an alkene or if it would have been an alkyne or alcohol, HNO3 would act in a different way. But in alkanes, it is going to replace one H, and definitely in the presence of sunlight only. So most of these reactions occur in the presence of sunlight. You understand? So in the presence of sunlight, it is going to be, this is going to replace one H. You understand? And it is going to be what?
Yeah.
It is going to form C, C, H, 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 H. And here it is going to be NO. So the name of the compound shall be nitroethane.
Well, what happens to the other hydrogen?
Any one of them
The
could be
replaced.
displaced. Any one could be displaced. You could displace this one. You could displace this one or this one. Any one of those. It doesn't matter. If you take an
No, the
example,
one that is displaced. The one that is displaced by the NO2. What happens to that one?
water is formed. Water
Right.
is formed. Yes. All right.
Yeah.
Okay. So this is how the structure shall be. It actually HNO3 could be written down like this if you understand. It is the structure of HNO3. So I hope you can understand that OH and H makes water. Do you understand?
Yeah.
If I'm able to explain it to you. So OH and H makes water, which is why water is being formed, and the remaining part shall be of NO2. Understood or not?
Yeah.
Right? So this is nitration of alkanes, which is where what is happening? One hydrogen atom shall be displaced by nitrogen gas or substituted by NO2 group. Understood or not?
Yeah.
Okay, so that is the concept. Next, you understand. Next part we have is of the sulfonation of benzene, the sulfonation of alkanes. So when we are talking about the sulfonation of alkenes, what do you think we add? We add here carboxyl. We add here concentrated sulfuric acid. So we have CH4, and in CH4, if you add concentrated H2SO4 in the presence of sunlight, so what is going to happen? What is going to happen? It is going to form CHNH NH. And the structure of H2SO4 shall be like this: OH SO3H. So this H and this OH shall form water, and the remaining SO3H group connects here in place of that particular H. So this H is basically being replaced by the SO3H group. So we call it as methane sulfonic acid. Methane sulfonic acid. Do you understand my point? Right or not?
Yeah.
So that is the concept. So for example, this is one. Second part would be carbon we have. So ethane, we have these H's right here. And if you add concentrated H2SO4 to them. So I hope you're understanding now. So what is happening in alkanes? The substitution is taking place. So based upon what is being, based upon what is being, so concentrated sulfuric acid. So it would be what? It would be like this: C H NH NH and C NH NH. So we have SO3H. Yes or no? And again, water shall be formed, and it was SO3H. So the name here shall be ethane, because it would have been ethane, but now one H is being substituted by sulfonic acid. Are you understanding my point? So it shall be
Yeah.
ethane sulfonic acid. Understood or not? Right?
Yeah.
So this is the sulfonation of alkanes. Understood or not?
Yeah.
Next possibility would be next possibility would be the bromination of alkanes. The bromination of alkanes. Now, what is bromination of alkanes? You understand? Very simple method. See, the only thing that you have to remember with bromination of alkanes is that they undergo substitution. All the alkanes undergo substitution. So, substitution reaction is actually a characteristic of the alkanes. I hope you're understanding what I'm saying. Right? So, similarly, when
Yeah.
I'm talking about the bromination of alkanes, what does that mean? What does that mean? Just see, alkanes, you can take any alkane. Like, so for example, if I say ethane. Now I'll teach you a new concept here. So simply you write down bromine and sunlight, right? So here you would require a little bit of sunlight and little bit of heat, both of them. So here, very simple. Normally, as we have been doing, what is substitution? One and one and one and C, NH, NH. And one H is being substituted by one Br. You understand?
Yeah.
And then what is happening? Another, because here it was Br2, so that would mean Br single bond Br. So I hope you're understanding. HBr shall be removed. So one HBr shall be formed as a side product.
Yeah.
Do you understand? So this is the concept. Next, what do you think we have in right here? If suppose we have this structure, tell me. If suppose we have this structure, C, single bond C, single bond C, H, H, H. H, 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 and we have Br2. Now you see. So the conditions you impose the same sunlight and heat. But what is happening, you see, these are all the chemical properties of alkenes, right? You can combust an alkane, you can calculate, you can do the bromination of alkane, you can do the chlorination of alkane, you can do the sulfonation of alkane, you can do the nitration of alkane,
Nitrate.
right? Now here you understand. Here, if you substitute this H, which is carbon number one's H, so product shall be formed as one bromopropane. But here, if you substitute this blue H, the product form shall be two bromo H. So here, that means two products shall be formed. Now, if I substitute this blue H as well, the green one,
One bro.
the so basically green and red is exactly similar. So no need to discuss them differently. But I hope you're understanding the final products that I'm going to get if I replace the the red hydrogen, I would get this product. I would get CH3. I would get CH3, CH2, CH2Br. At the first position, I'm going to get Br. I hope you're understanding.
Yeah.
Plus, what extra do you think I'm going to get? I am going to get, see this,
HPl.
CH3, CH, Br, CH3. Are you understanding?
Oh, so you get both of them.
You will get both of them. That's the difference. So you have not asked me the question up till now that, ma'am, in the previous examples, you have given me examples of only methane and ethane. What about those where there are more than two carbons? So then we have both of them. So here we get one bromopropane, and we get two bromopropane.
So in case of pentane, it can go up to three.
Exactly. So we get mixtures of
Okay.
the propane, and one of them will be in maximum quantity, one will be in the less quantity. You understand? But we get both of them. So this is
Okay.
how bromination takes place because every hydrogen then is different.
So this is applicable to all of them with nitrogen dioxide and the sulfuric acid and all, right?
Yes, 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 yes. But primarily we discuss that generally in bromination and chlorination because here the yields are more. With concentrated H2SO4 and with concentrated HNO3, you see there are other different types of products being formed because concentrated H2SO4 and HNO3, that is a very strong oxidizing agent as well. So they generally end up giving the oxidized products more. So that is why. So for chlorination and bromination specifically, we discuss every type of alkane, like more than one carbon, two carbon, three carbon, and so on. You understand? And here, this would be a
Okay.
major
Yeah.
component, and this would be a minor component because both the hydrogens are different. And how do I know that these compounds are different? Just write down their names. If you are finding the names to be different, even in terms of this number, you know, just understand that this is going to be my different compounds are being formed. So I'm going to get the isomers here. You understand?
Yeah.
Next, what do we have in here? Jesse, write down. Next, we are going to discuss about another that shall be the fluorination of alkenes. That shall be the fluorination of alkenes. Now, what is fluorination of alkenes? Just understand. Fluorination of alkanes occur in a very different way. Fluorination of alkanes is like, write down, fluorine has a very strong affinity for hydrogen. Fluorine has a very strong affinity for hydrogen. So when fluorine has a very strong affinity for hydrogen, see if I have methane, CH4 plus fluorine, and you don't have to heat it in sunlight or any heat you have to provide, this can reaction can occur in dark. Fluorine is very, very reactive, very, very reactive, extremely explosive and reactive. So you would not believe that all the hydrogens would be taken up by fluorine, and the reaction would be something like this. So it is going to become C. F4, CF4 plus HF. So all the hydrogens here, not one, in a single step, all the hydrogens here would be replaced by fluorine. So if you have these four hydrogens being connected here, and if I'm combining with fluorine, so what do you think I will get? CF4. You understand? And all the H is being replaced by
Yeah.
what? By fluorine. So four fluorine molecules would be required basically. You understand this way? Like the way I write it down this way, right? If I write it down HF, if I write it down FF, FF. So one H with one F, then another H with this H with this F. I hope you're understanding.
Yeah.
So 4HF shall be formed, and 4H here they will combine with the carbon atom. Understood or not? So this
Yeah.
reaction is very, very explosive. I hope you're understanding. On the similar lines, for example, if I say this part, on the
Yeah.
similar lines, if for example I say this part, if I say C2H6 plus fluorine, and here I'm going to put a dark condition. So basically, understand that fluorine has a very strong affinity to extract hydrogen. You never know wherever hydrogen is, it is going to attract hydrogen, and you're going to get C2HF6, and HF shall be formed. You understand? So this is going to be 6HF. So this is how the product shall be formed. Understood or not?
So HF is formed in all of these fluorine
All of these
reactions,
carbon.
right?
Exactly. Fluorination will pattern